In the last part of this program, we looked at how to move a single-phase line using the lift method and using the side method. The principles of these two methods can also be applied when moving three-phase lines. Three-phase lines can be moved using wire tongs, 2 for each phase conductor, but the worksite gets quite congested with all the tongs and saddles that are needed. So instead, a hotline tool called an auxiliary arm is often used when three-phase lines need to be moved. One type of auxiliary arm is the sidearm, which holds 2 of the 3 conductors off to one side of the pole. A second type of auxiliary arm is the mast arm, which holds all 3 conductors above the pole. In this part of the program, we're going to look at these 2 types of auxiliary arms and how they're used when moving three-phase lines. We'll start with the auxiliary sidearm. The auxiliary sidearm is constructed of 2 hot sticks. One is the auxiliary arm, and the other is a wire tong. The auxiliary arm is a heavy-duty insulated hot stick. A variety of hardware is mounted on the arm, such as these 2 wire holders. The wire holders are separate brackets that are clamped onto the arm and can be positioned as needed for the required phase separation. Also mounted on the arm is a wire tong arm stirrup. The stirrup provides a connection point for the wire tong, which is used to support the auxiliary arm. At the other end of the arm is a permanently mounted clevis. The auxiliary arm clevis is mounted to the utility pole by pinning it to a wire tong saddle clevis. The 2 ends of the arm clevis fit on either side of the ends of the saddle clevis, and a pin is fitted through the holes of all 4 ends to hold the auxiliary arm to the wire tong saddle. The ring end of the wire tong is also pinned to a wire tong saddle clevis. The basic principle for moving three-phase lines when using an auxiliary sidearm is to use 2 wire tongs to move 2 of the conductors to the wire holders on the sidearm. The 2 wire tongs are then used to move and hold the 3rd conductor out to the opposite side of the pole. In addition to the auxiliary sidearm, the other hotline tools that are used are pretty much the same tools that were used for the side method of moving a single-phase line. However, since this procedure involves 3 phases, additional cover gear is needed, including cross-arm covers, insulator hoods, and conductor covers. Some of the steps for moving 3-phase lines using an auxiliary sidearm are the same as for moving a single-phase line. We'll concentrate on those steps that haven't been covered previously. As shown here, more cover gear is used for 3-phase hot stick work than for single-phase work. After everything's covered according to company policy, the linemen mount the first wire tong saddle clevis just below the crossarm braces. This is the clevis that will secure the auxiliary arm to the pole. Next, the auxiliary arm with the wire holders and wire tong arm stirrup already installed is raised up the pole, and the auxiliary arm clevis is pinned to the wire tong saddle clevis. Farther down the pole, they install the wire tong saddle clevis that will secure the sidearm wire tong to the pole. The wire tong is clamped onto the wire tong arm stirrup. The sidearm is raised so that it extends horizontally from the pole, and the wire tong is secured to the saddle clevis. The sidearm should be level. If it is not, the saddle clevis that is holding the wire tong should be moved up or down to level the sidearm. After the auxiliary sidearm is in place, the linemen attach 2 saddle clamps to the pole, clamp 2 wire tongs onto the outside conductor that's on the same side as the sidearm, and secure the wire tongs to the saddle clamps. Then, as one lineman begins to remove the tie wire from the conductor, the other lineman attaches a block and tackle to the lifting tong. When the tie wires have been completely removed, the conductor can be moved to the far wire holder on the auxiliary sidearm. One lineman controls the holding tong, a second lineman controls the lifting tong, and a worker on the ground controls the rope for the block and tackle on the lifting tong. The three crewmen work together to lift the line off the insulator and carefully move it to the far wire holder on the auxiliary sidearm. As the conductor is lowered into the wire holder, it pushes past a safety latch. The latch swivels back into place and locks the conductor in. Notice that the wire holder is mounted on top of an insulator. Depending on company safety policies and the voltage of the line, insulators may be required on auxiliary arms for circuits above a given voltage. The wire tongs are then moved to the center conductor, which is untied and moved to the other wire holder on the auxiliary sidearm. Finally, the wire tongs are moved to the outside conductor that is on the opposite side of the pole from the sidearm. This last conductor is moved out to the side of the pole, opposite the auxiliary sidearm, and the saddle clamps are tightened to lock the wire tongs in place. With two of the conductors supported away from the pole on the auxiliary sidearm, and the other conductor held out by the wire tongs, the linemen have the clearance they need to work on the crossarm and insulators. When the work is done, the conductors will be moved back to their insulators in the reverse order from which they were taken off. To release a conductor from its wire holder, the safety latch is flipped to the open position using a hot stick. Then the conductor can be lifted out of the wire holder and moved back to its insulator on the crossarm. Many of the basic steps for moving three-phase lines using an auxiliary sidearm are the same steps that are used for the side method of moving a single-phase line. The obvious difference is that a sidearm is constructed, installed, and used to support two of the conductors after they're removed from their insulators. Now, while the auxiliary sidearm is used with the side method of moving three-phase lines, an auxiliary mast arm is used with the lift method of moving three-phase lines. Let's take a brief look at the auxiliary mast arm. The basic construction of an auxiliary mast arm includes an auxiliary arm which is supported in the middle by a heavy-duty mast pole and supported at its ends by two wire tongs. Three wire holders are mounted on the arm. The wire holders are spaced so that they line up with each of the three conductors on the utility pole. The mast pole is secured to the auxiliary arm by a mast pole clamp. The wire tongs are clamped to a wire tong stirrup that is mounted at each end of the auxiliary arm. The ring ends of the wire tongs are secured to the lower end of the mast pole by a wire tong pole clevis. The basic principle for moving three-phase lines using an auxiliary mast arm is to lift all three conductors straight up at the same time. To secure the mast arm to the pole, two wire tong saddle clamps are used. One is located just below the crossarm, and the other is located just below the pole clevis that holds the ends of the two supporting wire tongs. A block and tackle is connected to the upper saddle clamp and to the bottom end of the mast pole. Here, the two outer conductors are already engaged in the outer wire holders. The center wire holder is lined up directly below the center conductor. Depending on company policies, additional insulators may be used to raise the center wire holder up so that it engages the center conductor. Here, a lineman secures the center conductor with a shotgun. The mast arm is slowly raised, lifting the outer conductors off their insulators. The lineman releases the shotgun when the center wire holder engages the center conductor, and the three conductors are lifted high enough to provide the needed working clearance. Moving three-phase lines requires a little more planning and preparation than moving a single-phase line. But when you use an auxiliary sidearm, many of the steps are the same as for moving a single-phase line using the side method. And when you use an auxiliary mast arm, many of the steps are the same as for moving a single-phase line using the lift method. Now, much of the hot stick work that we've looked at involved removing ties and moving conductors. That's because these tasks are necessary for most distribution line repair jobs using hot sticks. But for some jobs, they're not. As we'll see in the next part of this program, when we look at how to change out a dead-end insulator using hotline tools.